All right, ladies and gentlemen, the next skill that we need to learn is how do we graph a system of inequalities? Okay, so what I have shown here on the screen is we have linear inequalities, but they're not a system. There's only one of them. And the reason being is because I want to show you like there's different things that we also need to be careful of when we're dealing with inequalities and graphing them on a coordinate plane here. So when you look at this equation here, it's in slope-intercept form, and all of our equations that we're going to be dealing with this week are in slope-intercept form. Of course, in slope-intercept form, you typically have an equal sign. But here, if you look closely, we're dealing with an inequality sign. And remember, there's four different inequality symbols that we are going to be dealing with. We have less than or equal to, greater than or equal to. We have less than, greater than. These particular symbols require unique ways to show what those symbols are graphically. So if you look closely, I mean, there's lines and shading, because if you think about it, if we're dealing with something that's greater than, like let's say we had x is greater than 5, is 10 a solution to that inequality? Yes, because we're dealing with any number that is greater than 5. 10 is greater than 5. So, there's a whole, infinite number of solutions that you could have based on that inequality of x is greater than 5. So when we're dealing with a linear inequality, it says y is less than or equal to x minus 4. Here we are in slope-intercept form. We can use our slope, we can use our y-intercept to help us graph those particular lines. Now, of course, we would always start at -4, and then we know that our rise over run here, because we assume that to be a 1, we would be going up 1, right 1, up 1, right 1. And the deal is here, because it can equal the value that's to the right, we would designate that with a solid line. Now, let's say we had an inequality symbol that, like say down here, where it is just greater than. What that would be is represented by a dotted line. That means a point cannot land on that particular line here and be equal to what we're talking about here and what is represented in our inequality sentence, if you will. Okay. So when we're dealing with equal to, whenever there's an equal to line, we're talking about a solid line. Okay. Whenever there's not an equal to sign underneath that inequality symbol, we're dealing with a dotted line. Okay. And dotted lines can be dashed or dots, whatever you feel is best. Usually dashes work best to represent. The other portion, or the other half of, if you will, of graphing linear inequalities is being able to shade the section that represents that inequality symbol. So if we're talking about anything that is greater than or equal to, we're going to be shading above that particular line. So if you look at this symbol here, it's a less than or equal to. And when we're talking in terms of y, remember, y is our vertical component. So whenever we're talking about something that is less than in a vertical, we're talking about whatever's below. Okay, so in this particular line, they shade below. So we're going to be coloring in, our different graphs and everything like that. So that's important to know. Here we're dealing with a greater than or equal to sign. Okay, and so again, we would start at +2 for our y-intercept, and then we would use this information to find our next point. Well, since we have a negative here, we either assign it to the top or the bottom. So we either go down 3, right 2, or we would go up 3, left 2. And there's our points on that line. That's how we know where we can draw it. And then because we're dealing with an equal to sign, we're talking about a solid line here. That's why you could see that as a solid line. And then also, because we're dealing with greater than, we're shading above. Not shading to the right or left. That would be in terms of x. We're shading above or below because we're speaking in terms of y when we're dealing with the slope-intercept form. Okay? So let me show you some examples of how this kind of works in a system of inequalities. Okay, so here's an example. So we're going to use this information down here to help us know what to do. All right, so first things first, I'm going to pick a color. I'll pick green here, and I will use this as my red. How about that? And then I'll use this as my green. Okay, so for our red line, we start at -3. That's our y-intercept. And so I would come down here and make my point. And then, of course, our slope here is 5. Better said is 5/1. So that means we're going to go up 5. 1, 2, 3, 4, 5. And then we're going to go right 1. And there's our next point. Now, since we have our 2 points, I'm going to look at this information here. Because it is not equal to, I'm talking about a dotted line, okay? And I'm going to put this as a shaded line here. It's awful, but you get the picture. It cannot, we can't have a point that is located on that dotted line here. And our last part is we need to shade everything that is above. We're looking for anything that is greater. So what I'm going to do is I'm going to shade this region here. I don't want to put too much there because you'll see in a second what that kind of looks like. Okay, now let's look at our green line. Here we're starting at +3. So I'm starting at +3 on my y-axis, and then our slope here is -1, which really means, it's really -1/1, which means we go down 1, right 1, down 1, right 1. Now, could you use your graphing calculator? Yes, but you got to be careful because with the graphing calculator, you're talking about equations. So there's no shading. We can't graph inequalities on our TI-84s as of right now, but I'll look into that more. Okay, again, going back to this problem here, because there's no equal to sign, I'm talking about a dotted line here. So I'm going to make a dotted line that zips through my line here. And then we're shading everything above. Okay, so I'm going to shade everything that is above this way. Ooh, okay. And then our last section is we want to really color in the section where we have where it crosses over, where we're both shaded, where both regions are shaded. So for this part, because we're shading everything above this red line and everything above this green line, I'm going to color in the section that where both of those graphs are true. And this right here is our solution area for our particular graph. It would be all the way up here, just this little section. Okay, so you can see how this can get kind of tricky. Let's do one more problem. We have our red graph up here, so I'm going to start at -3. And then I'm going to go, well, my slope is +1, so I'm going to go up 1, right 1. Okay, I'm going to make all these points here. And again, we're dealing with a dotted line. As you can see, there's no equal to sign. So I'm just going to make a dotted line here. Okay, and you can kind of see it there. And then finally, seeing that it's a greater than symbol, I'm going to be shading everything that is above here. So I'm just going to put these lines that kind of like thin out above. Finally, our last line here is we're going to have +3. So I'm going to start at +3. And now our slope is -2, which is better written as -2/1, which means our rise is -2, which means we go down 2, right 1, and down 2, right 1. So you can keep on going. Down 2, right 1, down 2, right 1. Or I could put the negative at the bottom, up 2, left 1. There we are. We're dealing with a dotted line because there's no equal to sign here, okay, with this green. So you will need 2 colors, or just have to be careful with how much you shade and everything like that. And then finally, we are shading everything above this line. Okay, so we're going to be going up this way. And then you can see the section where it kind of crosses over is going to be this section right here, where it's above the red line and also above the green line. So I'm going to pull out my blue here, and I'm going to shade this particular region that's above the green line and above the red line, which is my solution area. That means any solution in this particular area is going to work for both equations. Just above the red here, okay, and below the green would only work for the red. Okay, any ordered pair would only work in the red section over here. But in this blue section, any ordered pair would be a solution to the top and bottom inequality. Okay, I hope this helps. Definitely looking forward to working with you in office hours. And please email me or message me if you have any questions with any of this skill. So do that practice problem. Do those practice problems that are embedded in this in our Google Classroom, and I think you're going to be in good shape.